Hello friends, in this video lecture, I will explain about the basic concept and operation of the inverter. On the Google, you can find n number of the circuit diagram of the inverter, but here you can design your own inverter based on the power rating of the inverter. So please be there in the video lecture till end and you will get the fundamental knowledge of the inverter.
Hello friends, in this video lecture we will discuss push-pull square wave inverter basics. So what is the requirements that we will understand first? So we required a switch. It can be MOSFET, MOSFET, IGBT or power transistor, power transistor, power transistor, which can used based on the our power requirement of the inverter. Then we require a center tape power transformer, which is look like this. Okay, this is its symbol and this is the transformer. Then we required a driver and protection circuitry, so which is this one, and based on this driver and protection circuitry we can run our inverter and drive the inverter section to get the our high voltage output of 230 volt. Then we required a battery, so here the battery I have shown. This type of similar battery we have to require to make a inverter. So this battery can be 12 volt battery, 24 volt battery or 48 volt battery inverter by putting this type of same battery in series parallel combination. So what type of inverter we are going to design, based on that we have to require the battery voltage plus its EH value, ampere hour value, so that if ampere hour is more, then what will happen, you can get more backup time from the inverter. So I think this you have understand. Now we will go for the basic diagram of inverter. So here I have made the diagram. This is the basic diagram of the inverter, in which the transformer is connected in such way that so that its secondary is in higher side. So this is the secondary and this is the primary in this condition when we are making a step up inverter. Okay, so here the secondary output voltage will get 230 volt RMS and the primary voltage is 12 volt we are giving with the help of battery. So we have designed for, we have taken 12 volt battery here, VDC. Just for the example I am telling, with the help of 12 volt you can choose whatever voltage of battery you have it. Based on that we have to design the inverter transformers and output will get it. So this is the battery 12 volt. Now the switch, here the switch is taken MOSFET. So the MOSFET Q1 and Q2, two numbers we require based on the power. If power is less, then this single two MOSFETs are sufficient. If power of the inverter is more, output power, you want more output power like 2 kilowatt, 5 kilowatt, then we have to connect more number of the MOSFET in parallel. Like this, we have to connect the MOSFET in parallel of the each other like this, and same here also we have to connect it to increase the power rating of the system. Okay, and the gate drive will connect individually with one resistor and to the gate circuitry like that, same here also. Okay, so in this manner we can increase the power rating of the system. Okay, so now I will explain uh, its functionality, how it will work. So before that I will define it here. This is the G1 trigger pulse and this is the G2 trigger pulse. Gate trigger for the Q2 and gate trigger for the Q1. If I will trigger this Q1, then this will on, correct? And if I will trigger G2, then Q2 is on. On means it becomes a short. Then this becomes a short. Then only my transformer will get the input voltage from this section, and then output will generate it accordingly. Okay, so before understanding this functionality, first we have to understand what is the drivers are required and what driver pulse are giving. So this G1 and G2 are getting from the driver. So this is the G1 and this is the G2 are getting from the driver IC. So driver IC can be CD4047. This circuitry you can find it out on Google if you search it. So many circuitries are available, and then one more IC is there, SG3525. This is also PWM IC. This both are the PWM IC, can generate the PWM with complementary pulses. Okay, so what is the complementary pulses, that I will explain you. So these are the gate drivers, sorry, PWM driving IC, and it's having some protections also. So I can say this is the gate driver with protection, gate driver and protection circuit. So based on this we can drive the system. Now we will understand what is the complementary pulse and why it's required. So here that complementary pulse are G1, G2. How previously we discussed G1 and G2. So this is the G1 and this is the G2. We have to give it. So complementary pulse is nothing but when the G1 is on, that time G2 is 0. You can see it here. When the G1 is on high, that time G2 is 0. When the G2 is high, that time G1 is 0. Means when G1 is on, that time G2 is off, and when G2 is on, then G1 is off. This is complementary pulse. But here one more condition is there, where G1 and G2 both are off. That condition is called dead band. That is a dead band, dead or dead zone. Dead zone means there is no operation is happening there. There is no one is on, either G1 or G2. Both are sleeping mode, or you can say 0. Okay. Okay. So these are the, you can see the dead zone here, this one. I will highlight it. So here to here is the dead band. This part is the dead band. This line to this line is the dead band. Again here, this line to this line is dead band. From here to here, all are dead band. So this is the called dead zone or dead band. In this, no operation is happening by the gate driver or gate PWM IC. So what will happen? This is actually called as a complementary pulses. So no clash over will happen, no IGBT will damage by turning on both at a time, because dead band is there. When one is on, then another is off, when another is on, another is off. Like that is it was there. Okay. Now we will understand the its function, how the function is happening and generate the output voltage. So these two gate pulses are very important. Okay, that only will drive the our switches. Switch can be MOSFET, IGBT or transistors based on the design of the inverter. So here you can see the battery is connected, battery positive is connected to the transformer 0, means this is the primary side, low voltage side. Low voltage center point is connected to the battery positive, and another 2 points, let us say 12 volt, is connected to the each MOSFET drain portion. So this is the drain portion. Okay, or if it is a transistor, then it is a collector. So collector position, positive position you can say. Then secondary of the transformer is the output, where we are getting the final output when the transformer action will happen by induction principle, and the induction only happen when the switch is operating. Okay, in the DC condition there is no operation of mutual induction because flux will not alternate. Hmm? So, and this section you can see here one small inductor and capacitor I have placed, that I will explain later. Before that, you just see the output waveform. You assume that these two are not connected. Okay, so up to this point you will see the output what is coming. So when, let us zoom here, when G1 is on, this gate pulse is on. So what will happen? So that gate pulse is G1, this one. So this transistor is on. So when this transistor is on, then you can see the battery, this loop is become as a closed loop. So what will happen? Current will flow from the battery and going from like this and coming through the switch and going to the battery. So direction of current will flow anti-clockwise in this direction, anti-clockwise. Okay. So when this is going anti-clockwise, what will happen? Here flux will change and the potential generated in the secondary. So this become as a positive and this become as a negative. Okay. So when this is a positive, so what will happen? This side pulse is generated. So I can take when the current is this side, it will depend on the polarity of the transformer, how you are taking the output. If this is the polarity and this is the dot point for this, then it will give it the output like this only. So that time, that time when the current is flowed in this direction, then here also voltage will generate. So that voltage is generated, this one. You can see from this point to negative side voltage is generated. Negative side voltage is generated. That is V out max. This is max voltage. So this voltage is generated, this part. And when, up to when, where the switch is on, until the switch is on. When the switch is off means after dead zone, the switch is off, then dead zone came, and then when the dead zone came, there is no operation. So what will happen here? Flux will not change and the output also will not generate as per the Faraday's law of the mutual induction principle. Hmm. So here the waveform is zero, current voltage is zero. In this condition, voltage is, output voltage is zero. And then you can see here, now gate pulse 2, second gate pulse is on. Okay, green one is on, so G2 is on. Now in this condition G1 is off. So what will do, I will erase this one because this current is not there. I remove this current, and in place of that current G2 is on, so current will flow. G2 is on, so this is on. So what will happen, again current will go like this, and going through the switch and come back to the battery. So in this condition current is flowing in clockwise direction like this, correct? So when the current is flowing in clockwise direction, what will happen? The polarity of this side also change it. Now this becomes a positive and this becomes a negative. And because of the mutual flux change, induction principles, flux is changing and then output is generating, and based on the turns ratio of the transformer, output voltage will get it. So polarity is changed. So you can see here, now when the gate 2 is on in the same period, this is output is generated. This output is generated. Okay. After that, you can see the gate pulse is getting off. So in same condition, the gate pulse is getting off. When the gate pulse is getting off, what will happen? There is no current flow. So I will remove the current. There is no current is flowing. If current is not flowing, what will happen? Output voltage I will get 0 because there is no change in the flux and output is not generating. So output is getting 0. So you can see one half cycle is completing this one half cycle is completing this one. So total cycle is become as a one cycle. From here to here is a one cycle, and the gate driving pulse frequency is 50 hertz because we want 50 hertz inverter. So the 50 hertz mean then this time period is 20 millisecond for a one cycle, one cycle, one cycle. And you can see after that when the G2 is off, and after that again dead band will come. You can see here dead band came. Then after dead band came, again G1 is on. So this each time cycle is repeating. You can see G1 is on and after that G2 is on. So up to here one cycle, and one cycle is repeating always, correct? So this cycle is repeating always. So based on like this, the output also repeating. This output is also coming, correct? So this is the generation of output waveform in the second secondary, V out. Okay, so in this manner output is generating. Now I will show you when you will, if you want a square in place of a square wave, because it is a generating a square wave. It is a look like a square wave. Okay, it is a square wave. So now we want sine wave, then we have to place some filter circuitry in the circuit. So I have placed LC filter, so that what will happen, I will get the waveform like this. This is the square wave we are getting previously, and after the placing the filter, what will happen, we will get the this look like a sine wave. This brown one is the final output of the filter. So we have to filter, design the filter, and then we can place it. But this filter becomes a very huge size. So I will show you one different combination of PWM is there. So here we are generating the square wave and converting into sine wave simply. But actually, if you see the SPWM, we have to generate SPWM signal. So based on the SPWM signal, we will get final output pure sine wave, pure sine wave, pure sine wave. Okay. Now, how we will generate the output for the gate drive? So we can use this IC CD474B. Okay, this is the monostable and unstable multi-vibrator IC. This we can use to generate a complementary pulses. If you see on Google, so many type of the inverter is designed is available on the Google with the help of this IC. This is also very good IC. I have also designed when I was designing a first inverter. Then I have used same IC and design. It was working very fine. But that is a high frequency inverters, not a 50 hertz inverter. And then next, you can choose SG3525 also. This IC, this is a very good IC for the designing any kind of the inverter. This is a very good IC. Okay, so we can design by it's having so many protection circuitry also. You can see shutdown circuitry. If you want any protection you want, you can give the command here, and then output will off, and then system will stop it. So overload protection, if you want to incorporate over voltage, you want to incorporate, we can incorporate with the help of these things. So these are very important. These details we'll discuss later. Okay, so in this waveform, in this manner we can generate the output from the square wave inverter. So this is the basic functionality of the generator. So this inverter will work, and I hope you will understand those working and its operation, how the transformer is connected with the battery and MOSFETs. So it's power based on the all those things are based on the power calculations, how much load you want to put. Based on that, you have to select this transformer, you have to select based this MOSFET switches or IGBT switches, and you have to select the battery voltage or its capacity. Because if you want to design high power, then you have to choose uh, series combination of the battery, means you have to choose the battery voltage to 48 volt. Because what will happen if power is more and you are selecting a 12 volt battery, so current will increase it, correct? Power, if you choose the power is then based on this, and if the power is same and battery voltage is more, then in that condition your current is reducing. In this condition your current, input current is increasing. And if the input current is increasing, means here the current whatever I shown previously, this current, this and this current value is increasing. And if current is increasing, then you have to choose that MOSFET power rating also based on that current. Otherwise, your MOSFET will burn out and your inverter will not work properly. And same manner, the power transformer rating also we have to choose it. Correct? So, we'll meet you in the next video lecture for the design. Thank you.